But I wanted to welcome everybody, because this is what I hope to be the first talk in a long line of talks about programming languages topics at Google that I'm trying to organize. The goal is to sort of expose all of you're all very smart people, expose all of your knowledge about language features and runtimes and upcoming changes to languages and software design principles, and get you all up here to give talks. We have some upcoming talks planned in a variety of things, including C++ and Python and Java. And API design. Josh Block will be giving a talk next week. But I wanted to take this time before Neal comes up here to make a pitch and really say that everybody can give a talk. You're all smart. You all know something really great about something. And you can talk about it for 45 minutes. And even if you don't know something great about something, you could learn something great about something and come up here and talk about it for 45 minutes. Giving a talk is one of the best ways to learn a topic that I know how to do, because having to explain it to somebody else is a really great way of forcing yourself to understand it. The topic doesn't have to be all that popular if you don't want. I've had people asking me, I sent out a message the other day, I have had people coming back and asking me if they can give talks on things like Eiffel and software transactional memories and domain-specific languages. It doesn't have to be as sexy as closures for Java. And if you give a talk, you get some cool free Google swag. So, and if that doesn't entice you, I can't imagine what will. So that's my pitch to you. Please give a talk. Contact me. I'm Jeremy Manson at Google. We have a wiki page. The talk series is called Advanced Topics in Programming Languages, so just look that up on the wiki. You can subscribe to the mailing list or add it to your Google Calendar. And with that, I will let Neal talk about closures. Neal is very impressive and famous, and you've all no doubt heard of him. He has a long history of giving these sorts of talks. And Closures for Java is just the latest in a long line of very good talks he's given. This is his proposal for a feature that is sorely wanting in Java, and his implementation of it for the next release, Java 7. And with that, no further ado, I will allow him to talk.
Thank you. So, thank you. So I want to start with a quote. This is something that Mark Jason Dominus said in a recent interview discussing his book, Higher Order Perl. In another 30 years, people will laugh at anyone who tries to invent a language without closures, just as they'll laugh now at anyone who tries to invent a language without recursion. And I think that's true. A lot of the languages that we're seeing being designed nowadays, or starting to see wider adoption, have closures as a very basic part of the language right from the very beginning. And I think Java sort of missed the boat on that, but it's not too late. Some people even think that Java maybe already has closures, and there are technical reasons why Java really doesn't have closures, and I'm not going to talk about the technical reasons. I'm going to really talk about the practical reasons why what is in Java right now doesn't satisfy what you get from the requirements that you solve by adding closures to the language. So here's an outline of the talk. I'm going to start by giving sort of a very high-level view of the goals of the language feature, what it is we're trying to accomplish, and a definition, what is a closure. I'm not going to go into a lot of technical depth about what the definition means, but it just sort of give you a feel for what it is. And then we're going to look in a little bit more detail at the existing solutions to these kinds of problems in Java. And we'll show some examples of using them to solve some existing problems. And you'll see where the shortcomings are, and that will lead to the requirements for what it is we want. What kinds of problems do we not want to have in the language once we have closures as a solution to these problems? And then that will lead into the specification. And I'm going to give you a high-level view of the specification. There's a lot more detail. There's a specification that's online that covers in a lot more detail what this is. I just want to start to give you a feel for what the specification looks like and what it would feel like to have closures in the language. And then I'll give some examples of what code might look like when you start using closures. And there are, in particular, you want closures to be able to work nicely with the existing language, not only with the existing language, but with the existing libraries. And I'll show that there are things in the specification to make it work very nicely with the existing language and the existing libraries. And finally, I'll talk about some of the kinds of new APIs you might want to add to Java as a consequence of, well, not as a consequence of having closures. You would want to add them now if only there was a way of expressing them. But there will be a way of expressing them once we have closures. So what's the goal? The goal is to enable something that I call control abstraction APIs. What these are, they're methods as part of APIs that act like new statements in the language. I'll talk about what that means in more detail in a moment. In addition, you want to be able to do the sorts of things that you can do with anonymous inner classes, but you want to do it much, much more easily than what you have to go through right now. So I'll call this concise function literals. You want them to work smoothly with existing APIs. So there are a bunch of APIs right now where you generally use anonymous inner classes with them. You'd like to be able to use closures with them and make those APIs easier to use. And I'll show you how that works. And there are all sorts of things that in the functional programming world you do with aggregate operations and higher order functions that are possible because you have function types and closures in those languages. Those sorts of things will start to be possible in Java, and I'll give you a feel for what those are. But mainly, the intent is for closures to be something simple. It's not supposed to be sort of an overarching reconsideration of the whole Java platform. It's supposed to be a sort of an addition that's orthogonal to the rest of the features of the language, that's straightforward, but it provides a lot of power and adds a lot of flexibility to the language that is lacking right now. In some cases, you don't even realize where it's lacking, and I'll sort of show you places where the power is lacking, and you really don't even realize it when you end up writing lots of boilerplate code. So let me start with the definition. What is a closure? A closure is a function that refers to free variables in its lexical context. Now, what is a function? Function is something that takes some parameters, does something, and might return some result. In a language like Java, that's not a functional language, but I mean, there is state and there is mutable state. The body of the closure might mutate something, might make some changes. And what is a free variable? A free variable is essentially a name that has a definition outside the closure. It's not defined by the closure, but it's used inside the closure. And you want those free variables in the closure to have the same meaning that they would have had outside the closure. So it's basically a lexical scoping. And I also mentioned that one of the primary goals is to enable control abstraction APIs. Now, control abstraction API, it's a new kind of statement form that is added to the language, but you add it to the language by writing a function. So the idea is it will be possible to write a method that acts like a new statement form. And they are ordinary methods, except they may happen to take a closure as one of the arguments. And the idea is you can start using methods to extend the language. And these are typically API specific. And this is the reason it doesn't necessarily make sense to add them directly to the language, is because they're specific to the API. Now, if you have an API that's in the platform, that's in part of J2SE, you might consider adding a statement form specific to those APIs. In fact, that is the approach that's been taken up until now. For example, you have the collections hierarchy. Well, in JDK5, we added this new for each loop. But it's really an API-specific statement. It's designed specifically to work with the collections hierarchy. If we had had closures in the language before JDK5, before we added the for each loop, I believe it would have been possible, instead of adding for each as a new language construct, to add it as a method in some utility class somewhere. It would have exactly the same syntax. It would have exactly the same semantics. You'd use it exactly the way you use it right now. But it wouldn't be a language extension. It wouldn't have to be known by every IDE. It wouldn't have to go into the Java language specification. It would be something that's documented the same way you document any other method. And you only need to know about it if you use it. And if you want to understand how it works, you go to the documentation. Or if you're using an IDE, you hover over the name of that method, and then the documentation pops up. So now I don't think there's a problem with the fact that that method's already there in JDK5. I don't think adding closures after the fact somehow makes a mess of the language. It is sort of unnecessary in the sense that that it's a statement that you wouldn't have had to have if you had closures first. But once you add closures to the language, there are lots of other places in the APIs where you actually want to have statement forms that are specific to those APIs. There are a lot of them in the JDK, and I'll talk about some of those. But there are also a lot of them outside the JDK where it doesn't make sense to add those language, those statement forms to the language because the APIs aren't even part of the JDK. And I'll show you some examples of that. But you want the statement forms to act like built-in statements. That's important, and I'll tell you more about what that means. So let's suppose you decided, without closures, to add for each loop as a library instead of as a statement form. How would you do that using anonymous inner classes? Well, you make a method, we'll call it for each here, okay? And it's going to take two things. It's going to take the collection, and it's going to take the block of code to execute once for each element of that collection. Well, how do you express a block of code? Well, it's an anonymous inner class. It's got to implement some interface. So here we make an interface. It has a method that takes one argument, and it's generic because we want this thing to work for any kind of collection. And here's the implementation of for each. It works for any type of collection. It takes a collection of T and one of these interfaces, a one arg of T block. And in the implementation, I'm using the sort of old style loops rather than using the for each loop because I'm assuming we don't have the for each in the language. So we go through the iteration, right, the way we would have done it before JDK5, except of course it's generic. And we call the invoke method on that block once for every element of that collection, right? This is very straightforward. What's the problem? I mean, why isn't this a good enough solution? What you see here is only one half of the equation. You see the unimportant half. This you only have to write once. But the person who uses this code, of course, there's going to be thousands and thousands or millions of people who use this code every day when they're writing loops. That's the important part, because that's the part that everyone has to read and write in their day-to-day work. So let's see what the client looks like. Well, this is the sort of thing we want the client to look like. Right? This is how the for each loop looks in JDK5. But if we're using this interface, this is what you have to write. For each, the collection, and then you have this long and complicated construction, which is the idiom for constructing an anonymous inner class in Java. And it is a little bit verbose. Maybe we could just make that a little bit shorter, right? Maybe that's the problem, is it's just a little bit too long. In fact, there is a proposal to shorten the syntax of anonymous inner classes, and that would make this a little bit shorter. You know, maybe you can remove one line or two. Maybe you can even remove 2 lines. In fact, maybe you can make it almost as simple as this. Maybe I cheated a little bit here by putting do thing on the same line after all. So maybe this solution isn't too bad. It's just a little bit verbose. But after all, this is a very trivial example. So let's look at a slightly more complicated example of a client. So here we have a client. It has a local method called toString that turns a thing into a string. And maybe the reason you want a method like this is the toString method that's a member of thing doesn't quite do the right thing. Maybe you need internationalization, or maybe it's too verbose and you just want a sort of summary. So we have our own toString method that we're going to use for the purposes of invoking inside this loop. And we go through this loop for each thing in this group of things, and we print the value of the result of this toString method on the thing. Okay, so we basically call our own method, and we print the result. Not very complicated. So here here's that code modified to use anonymous inner classes. But unfortunately, this code won't compile. What's the problem? Well, the problem is right here, the invocation of this toString method. And what the compiler is going to tell you about this is it's going to say, yeah, I found the toString method, but it doesn't take any arguments. I don't know why you're trying to pass an argument to it. So what is the compiler talking about? What the compiler's talking about is this anonymous inner class here extends object. An object has a toString method. And that toString method is inherited inside this anonymous inner class. And because the scope here is inside the scope where this toString method is defined, we find that first. Because that's the way lexical scoping works. You find the stuff on the inside before the stuff on the outside. So the compiler is going to find the wrong toString method. Well, OK, that's not a big deal. Maybe you can just say enclosing classname.toString. And wouldn't that solve the problem? Sure, that would almost solve the problem, except this isn't a static method. So we have to actually say enclosing classname.this.toString. Well, wouldn't that solve the problem? Yeah, that would solve the problem, unless the enclosing class is an anonymous inner class. Then it doesn't even have a name. In that case, there's no way to refer to it at all. And you simply can't do it. So, OK, well, that's fine. Maybe we just move the toString method somewhere else, or we rename it somewhere else. There are solutions to all of these problems. But this is where you have to sort of take a step back and say, what problem was I trying to solve? I'm just trying to write a loop. I'm just trying to print out the value of calling this function. Why am I fighting with the compiler? You see, anonymous inner classes, because they're not closures, they have all sorts of constraints. They have all sorts of semantics that interfere with your ability to refactor code. And this is an example of the kinds of trouble that you can get into. So the point here is, Java is a Turing-complete language, right? Adding closures doesn't change that. Anything you can do with closures, you can do without closures. But closures enable you to do things much more simply. And they enable you to refactor code in ways that are not possible without closures. When you use anonymous inner classes, you have to look at the body of what it is you're going to wrap in the anonymous inner class. That is, you have to look at this code inside the loop. And if you're going to wrap it in an anonymous inner class, you have to look at every single line and every single expression and say, do I need to modify this because I'm using it inside an anonymous inner class, and express that code differently to accomplish the same effect? It would be better if you could always express the same code, the same intent in using the same code. So here's another example. Let's suppose you, sometimes inside that loop, you want to throw an exception. Well, if you're refactoring your code to use an anonymous inner class, you can't do that, a checked exception. The reason you can't do that is this exception is not declared to be thrown by this invoke method. Well, can't we just declare it on the invoke method? Well, no. The problem is the invoke method in the interface that we're implementing doesn't declare that. So how do we solve this? Well, maybe we add another parameter to that interface, which is the exception that can be thrown. That works great if there's exactly one exception that can be thrown. But what if there's 0? Then you have to have 2 different versions, one for no exceptions and one for one exception. But what if there are 2 or 3 or 4 or 5? Do you have sort of an infinite number of these methods, one for every number of exceptions that can be thrown? And you're also sort of forcing the programmer to sort of explicitly write this exception over and over and over again out through any intermediate anonymous inner classes. It's quite awkward. So another example, what if inside the loop you sometimes want to return a result from the enclosing method? Well, you can't do that with an anonymous inner class because the return type is void. In fact, it would be, right, the compiler is trying to return from the wrong place. Because you've inserted a new method lexically enclosing the code that you're trying to put inside the loop, you can't use a return statement. In fact, you can't use a break statement to break out of an enclosing loop or continue an enclosing loop. Finally, let's suppose you want to say set a variable here, a local variable inside the loop. This is very easy to do using an ordinary built-in loop, but if you're using anonymous inner classes, there's a rule that says you're not allowed to use non-final variables, local variables from the enclosing scope. And if it's a non-final, if it's a final variable, with the only kind that you're allowed to use, you certainly can't assign to it. Well, there are ways around this. You can make an array of length 1, or you can make a little class that just contains all of the variables that you want to modify. Those are kind of ugly. Maybe you sort of refactor the entire method as a little class, and you make fields for all of the things that would have been local variables. You can do all of these things, but again, the point is, all of these refactorings of the program have absolutely nothing to do with the problem that you're trying to solve. You just want to find the value and return it from inside the loop. So these are all examples of the sort of trouble that you can get into using anonymous inner classes for the kinds of things that I think closures should be used for. Basically, they're quite verbose. You have at least 3 or 4 lines. Well, of course, you can put everything on one line if you want, but by the usual conventions, you have at least 3 or 4 lines when really one line would do. Closures, on the other hand, are intended to be much more concise and much easier to use in your code. The most important thing is the lexical context of the code is not completely captured by anonymous inner classes. The meaning of this changes. It refers to something different inside an anonymous inner class than it did outside. ToString or any of the methods that you inherit from object or from the interface that you're implementing, or the class that you're extending. All of those affect the scoping. Return, break, and continue simply don't work the same inside an anonymous inner class as they do outside. And of course, the non-final local variables from the enclosing scope, you can't use them. So the bottom line is, if you're using anonymous inner classes to do this kind of thing, you are going to be forced, whenever you try and use them, to examine every line of your code and figure out how to rewrite that code, or maybe you don't need to, but you're going to have to look at every line of code and think about what you have to do to make that code work inside the wrapped anonymous inner class. Because they are so difficult to use for these kinds of things, control abstraction is simply not possible. It would be impractical to add a for each loop as a library method using anonymous inner classes, because it would be unusable by people. There wouldn't be any point in it. It would be too awkward to use. And that's why we don't see these kinds of APIs in Java today. Not because they're not possible, but they're far too awkward to be practical. One more example in a little bit more detail. This is a program that you'd like to refactor slightly. This is how we hire people at Google. Okay, what we do is we have every candidate has a set of qualifications, right? These are all the keywords on their resume that they say the person, what do they know? They know Java, they know C++, and they're certified J2SE level 1 or whatever. So we have all these keywords. I'm not going to tell you what a qualification is. For the moment, let's just suppose it's a string. And we have a pool of candidates, which is the stack of resumes that we received in the past, I don't know, month or two or something like that. This is not really how we hire people at Google, by the way, just so you don't get the wrong impression. And the candidate pool is a collection of candidates. Okay, so it's just a set of people that we can consider to hire. And there's one more thing inside it. There's this lock object. Now, the reason there's a lock object is when say my group, Google Calendar, says, oh, we need another person, we want to go to that candidate pool, we want to shuffle through them until we find the person we want, and then we want to remove them. But we want to do that atomically. We don't want to find the person and then try and remove them and discover they're no longer in the collection because someone else hired them. So the idea is whenever you're doing a couple of operations on the candidate pool, you lock the lock, you search for the candidate you want, you remove them, and then you unlock the lock. That way you make sure that you have a consistent view for that short duration of time. And in fact, here's how we recruit someone, right? We have the candidate pool as an argument and the set of qualifications, and we're going to return a candidate. And what we do is we synchronize on the lock, we go through each candidate in the pool of candidates, and if the candidate's qualifications contains all of the requirements for the position, then we remove the candidate from the pool, and we return the candidate. We're done. We found the answer. And if we go through all of the candidates and we don't find anyone, then we call this other method that, for recruiting someone outside Mountain View. Maybe we try and find someone who's applying for a position in the Zurich office, for example. This way, hopefully, we always end up hiring some candidate. So this is straightforward, and this code is more or less correct, except there's one little problem. This code is not fair. You see, Google is hiring at such a furious rate that there's lots of contention for this candidate lock. There's so much contention that there are always people waiting on this lock, looking through the pool of candidates to find someone. And the problem is some groups get starved. Some groups end up waiting on this lock forever, never getting the lock and never being able to recruit someone. And some other lucky groups get to get people through the process over and over and over again. They get the lock. And that's because there's no guarantee of fairness in the locks that are built into the Java programming language. There's no guarantee, there's no first come, first serve, for example, when you try and lock something. But there's a really easy solution to this problem. In JDK 5, the concurrency utilities were added, and they're a very useful substitute for the built-in locks. And if you use those locks, when you create a Java util concurrent locks.lock, you get to pass a Boolean flag that says whether or not you require fairness. And if you say you require fairness when you acquire the lock, then it's first come, first serve. And this is actually very useful. We solved a severe performance problem in Google Calendar by replacing the ordinary language built-in locks by Java util concurrent locks. It was a fairly easy thing to do, and it solved a huge problem for us. And so we can refactor this program to use locks. Now, this is what I think the refactored program should look like. The lock method, instead of returning an object, returns a lock. And I've replaced the synchronized keyword with an identifier with lock. Now, the intent is this with lock method is one that you've statically imported from somewhere, say Java util concurrent.locks, some static utility method. And it acts just like a built-in statement of the language. It acts just like synchronized did, except instead of using the built-in locks, it uses the concurrency locks. So if you compare this with the previous slide, which I don't seem to be able to do right now, but basically this was synchronized. This with lock used to be synchronized, and this lock used to be object. It's the same code. But I want you to be able to, the idea of the closures proposal is that you should be able to write methods like this with lock method that behaves like this. And there are a couple things to notice about this code. Here we're referring to local variables from the enclosing scope that are not final. Okay? We have candidates and we have requirements. Now, we don't actually assign to those variables, so we could have just made them final. It's no big deal. But there's another thing in here is that we have a return statement inside this code. This return statement doesn't return from some closure. It returns from the enclosing method. And that's very important for this code. In order to make this refactoring as painless as possible, you don't want to change the meaning of the return statement when it's wrapped in a closure. So here's one more example from the Google Calendar code base. This is code that we have repeated in the Calendar code base hundreds of times. And this is the kind of code we use to time operations in the Google Calendar code base. So what we do is we take a snapshot of the system nanotimer. We set a success flag to false. And the idea is, excuse me, we'll set that flag to true when the operation completes normally, so we can distinguish failure from success cases. We have a try block here. We do the operation. And when the operation completes successfully, we set the success flag to true. And in the finally block, we have a method that we called record time, and that records, that gathers statistics of the running time of various operations. We have a string that identifies the operation we're timing. The success flag, so we can gather statistics separately for the success and failure cases. And finally, we take the current value of the nanotimer minus the initial time, so that's the elapsed time that was required to do that operation. Okay? This code works just fine. The only problem is it's repeated hundreds and hundreds of times throughout the Google Calendar code base, and it obscures the business logic of what it is we're trying to accomplish. Right? Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9 lines to do two things: the operation and to time that operation. And what I would really like the code to look like is something like this. I want to call a time method, pass the string that I need to distinguish one operation from another, and then just a block of code, which is a thing I'm timing. There's no way that an application-specific API like this is going to end up in the JDK. Although maybe you'd argue this is not specific to Google Calendar. Maybe anyone could use a timing operation. But does it require a distinction between the success and the failure case? Should it be a nanotimer or a microsecond timer? And there are many other examples that are really more deeply into the semantics of the application than this one is. In fact, I've abstracted away some of the things that actually are they're calendar specific about the way we do the timing. So this, I think, should help motivate the kinds of things I want you to be able to do. And that leads us to the requirements. So what are the requirements for closures? You should be able to write control abstractions. That is, you should be able to add statements to the language by writing methods, where those method invocations act like and look like statements in the language that are specific to your APIs. And they should be on par with the built-in statement forms that are in the language. They should allow you to, you can put an if statement around any block of statements. Well, you should be able to put your invocation of your API around any block of statements. You shouldn't have to refactor the code in order to make this work. They should be concise, that is, they should be very easy to use. And that's the previous slide I hope showed you. They should be as easy to use as the built-in statements are. And in the cases where there are things in the APIs right now that have this flavor, you should be able to use the syntax and the semantics and all of the benefits of closures without changing those APIs. You should get that naturally with the existing APIs. And I think we've accomplished those things. So let me show you what the specification looks like. And here's what I'm going to show you. There's really three parts to the specification. There's function types. There's closures. Those are values of function type. There's a control abstraction invocation syntax. It's a way of invoking a method that looks like a statement, but it really is just a method invocation. There's some things in the specification called transparency that I'm not going to talk about in detail. There's 4 of them that I've listed up here. Let me just give you an example. Exception transparency, that says that when you define your own with-lock API, for example, that you should be able to define it in such a way that any checked exceptions that are thrown inside are known by the compiler to be propagated out, and that the language's natural exception checking will work with those APIs. I'm not going to talk in detail about how those work. If you want to know more about those, you can look at the specification. I'll give you a URL shortly. I will talk, however, about interoperability, about how closures work with existing APIs. So, starting with function types, here are some examples of function types. Here's a function type for a function that takes an int and results in an int. Here's a function type for functions that take 2 ints and results in an int. So here's one a little bit more complicated. This is a function type for a function that takes a string and results in an int, but might throw number format exception. I'll give an example of a value of that type shortly. Here's a function type that doesn't take any arguments and doesn't return any result. Right? So an ordinary block of statements would typically be of this type, where it doesn't take any arguments and doesn't return any result. And finally, if you're in generic code somewhere and you have type parameters floating around, you can write a function type using type parameters. So here's a function from T to U. That's just fine. Function types are ordinary types. You can take them as arguments. You can return them from methods. You can have variables of function type. You can have a function type that takes a function type as an argument and returns another function type. Basically, anything that you can do with an ordinary type, you can do with a function type. So a little bit more formally, here is the grammar rule, the syntax rule for how you write a function type. It's an open curly brace. It's a list of types. And that's optional because you're allowed to have a function type that doesn't take any arguments. Then you have a fat arrow, equals greater than. And then you have a result type. Now, you always have to write a result type, but if you don't have any result, you can just write void. And then optionally, there's a throws clause. So throws, number format exception, for example. And the idea is, or more than one more than one type you can list there in the throws clause. So the throws, the type that can be thrown by a function type is part of that function's type. And finally, there's a closed curly brace at the end. So what is the meaning of a function type? Well, this particular one, the function from string to int that throws number format exception, that is a shorthand for a particular interface type. So function types are interface types. They're not a separate extension to the type system. If you understand interfaces and generics and perhaps a little bit about wildcards, then you already understand how function types work. This is shorthand for java.lang.function.io of string, comma, number format exception. Well, what's this IO? The idea is the name of the interface is taken from the signature. And it uses the conventions of the VM signature of methods. So you start with the return type, or the result type, I should say, and that's int. And you represent that in a signature using a capital I. And then the argument types are listed, except any argument type that is an object type is simply listed with a capital O rather than describing the exact type. And it becomes a type parameter. So in this case, our argument type is an object type. So we have a type parameter in this. And the type parameter is filled in with string because that's the argument type of this function type. And there's always another type parameter for the throws clause. And it turns out if it doesn't throw anything, you can put null in there. And this function type IO looks like this, interface IO, A for the argument type, and it takes a type parameter that extends exception because that's the throws type. And the method is always called invoke in these function types. And in this case, it returns int because that's the one it is. And it takes an argument type A, and it throws X. Now, you might be wondering, am I going to be typing in a million of these function types and putting it in this package Java lang function? The answer is no. These are generated on demand. In the same way that array types are generated on demand by the VM, any of these that you need are just there. Okay? If we add this language extension in JDK7, you could simply write java.lang.function.io in your program, or IIIIO. And those types are all there. Or you could use, more likely, you'll want to express it this way with the curly braces. Now, the compiler, when it gives you error messages, hopefully will give you error messages in terms of the function types that look like this, rather than function types that look like this with the angle brackets. Because hopefully people will be thinking in terms of function types rather than thinking in terms of these interfaces. That's all there is to it. No, that's not quite all there is to it. It turns out we actually use wildcards in these arguments as well, so that function types are covariant in the return type. And we use wildcard types in the argument type, so they're contravariant in the argument types. Mostly, you don't have to worry about that, except that it does some surprisingly useful things where you would hope it would, and you simply don't have to worry about it. I'm not going to talk about that in detail, But if you want more detail, you can look at the specification, which I will give you a pointer to at the end. So again, function types are ordinary interface types. They're not new types that are an extension of the type system. And function types always have an invoke method. You need to say .invoke if you're invoking the method of a function type. You can extend them, just like you can extend any interface type. You can make an interface that extends them. You can implement them. Well, why is it important to be able to do these things? Well, let's suppose you want to be able to serialize one of these things. Maybe it's part of a serializable data structure, or maybe you want to express something that you want done on the other end. You can make these implementations of these function types serializable simply by implementing them in a serializable class. And you could even make a custom serial form if you wanted to. And again, you can declare variables, parameters, return types. All of the things you can do with ordinary types, you can do with function types. And there are no special type rules for these function types. They simply obey the type rules of interfaces and generics. So now I'm going to tell you a little bit about closures. Here are some examples of closures. So here's a closure that takes an int variable or an int value and results in that value +1. Here's one that takes 2 int values and returns the sum of them. So here's one that takes a string called x and returns an int, which is the result of parsing that string. But this closure might throw number format exception. So the compiler knows from the body of it that it can throw number format exception. So this is a closure of the function type that we analyzed in more detail a couple slides back. Finally, here is a closure that it doesn't take any parameters. It just prints something on the output, and it has no result. It has a void result type. And you can tell it has a void result type because there's a semicolon here. There's no final expression. It's just a statement instead of expression. So if a closure has a result, it's the final expression inside the body. If there is no final expression, then the closure has a result of void. So here, a little bit more formally, is the syntax for a closure. A closure is a kind of primary, and it starts with an open curly brace, and then you have your formal parameter declarations. Optionally, you're not required to have any parameters. Then a fat arrow, and then a bunch of block statements, but those are optional. You don't have to have statements. And then a final expression, but again, you don't have to have a final expression. It could just be statements. And finally, a closed curly brace. Yeah.
Does it make sense to ask if these should be parameterized by type?
Does it make sense to ask if these should be parameterized by type?
Yeah.
I think the answer is no. I haven't come across any situations where that would make sense. Maybe, I don't know. I haven't come across a need for that kind of thing. So what is a closure? What is the semantics of a closure? What does a closure mean? Well, closures don't add very many restrictions to the statements and expressions that are within them. You can access local variables from the enclosing scope. They're lexically scoped. You can return from an enclosing method. You can use the variable this. It refers to whatever this meant in the enclosing method. It doesn't refer to the this of the object that contains the method that the closure implements. It means the same thing inside the closure as it meant outside. However, there is no way to yield a result early from a closure. Okay, I mentioned that a return statement returns from the enclosing method. There's no equivalent of the return statement inside a closure. That means, oh, I found the answer. I really want to just get to the end and produce this result. You can assign it to a variable, and you can break from a statement in order to do that. But there is no syntax inside of a closure that allows you to produce that result early. And that's actually important. It turns out that if you try and add a syntax to do that inside a closure, you can no longer use it to write control abstractions. I'm not going to explain that in detail. It is a little bit of a counterintuitive result. But if we have time at the end and someone cares, I can explain that. Yes? So your question is, does that mean you can break or continue inside a closure? Okay, so I think I know where you're going with the question, but I'm not going to repeat the question, but I'm going to give you an answer that probably won't satisfy you. You can break inside of a closure, and the break statement breaks from the nearest enclosing loop or switch statement. Okay? You can continue inside of a closure. It continues the nearest enclosing loop. If you want to use closures to write your own loop constructs, I'm not going to tell you how to do that, but there are ways of doing that. Yeah.
Do we get continuation for free for this? Can I make a closure which just calls return and assign it to a global?
Right. So the question is, do we get continuations for free using this? In the current form of the specification, the answer is no. If you attempt to return from a method that's not on the current call stack, you get an exception. And that's specified in the current form of the specification. However, you can do things that look an awful lot like continuations if you're careful using closures, but I'm not going to talk about that either. Okay, so there's one more thing that you need to know about closures, and that is something called the closure conversion. So the idea is, I talked about function types and I talked about closures, but I didn't tell you what the type of a closure is. Presumably, it corresponds to some function type. Well, the answer is no, not quite. The closure, when it appears in a program, is converted to some interface type. But the compiler doesn't always choose sort of the obvious function type for the closure. Instead, the compiler is required to look at the context in which the closure appears and choose an appropriate interface type. So for example, if the closure is being assigned to a variable of type runnable, then the compiler is responsible for turning that closure into an object that implements runnable, which means you're going to use the .run method to invoke the closure. And anywhere a closure appears in the program, where it has a target type, the compiler is required to try and produce something of that target type. If you're returning a closure, whatever the return type of the current method is. If you're assigning to a variable, whatever the type of the variable is. If you're passing it as an argument to a method, whatever the argument type of the method that you're invoking is. That's the target type. And when you have a closure appearing in the program, it is converted to the target type. Now, occasionally, you might have a closure appearing in the program being assigned to something like object, where there is no target type. In that case, it's turned into an instance of the natural function type. That is the one corresponding to exactly the function type with the same return type and the same argument types and the same throws clause. But in most cases in a program, there will be a natural interface type where the closure appears, and that's the type you want the closure to produce. This is important for providing interoperability with existing APIs. Because we have existing APIs where you register a swing callback, or you have a runnable you want to submit to an executor as part of the concurrency framework. Lots of places where you currently use anonymous inner classes. Because of the closure conversion, you will be able to start using closures in those places instead of anonymous inner classes.
Question?
Yes.
Is this conversion strictly a compile time activity, or does it have...
Excellent question. So the question was, is this conversion strictly a compile time activity? And the answer is yes. Sort of a closure in isolation doesn't need to generate any code. If you don't assign it to anything and the user can never get his hands on it, then you can't do anything with it. So the compiler applies the closure conversion always to every closure that appears in the program, and it decides there on the spot at compile time what interface type it's going to construct. So there's no runtime performance penalty for the closure conversion. It happens entirely at compile time. Yes?
Does that mean there's sort of a debugger penalty? That a debugger won't really see what the user thinks of as their code?
So the question is, does that mean that there's a debugger penalty, that the user won't see what the user thinks of as their code? Well, the line numbers are going to point to the right line. But if you're wondering what class he thinks he's going to be executing in, it will act similar to the way an anonymous inner class will act, in that you'll know what source file you're in, you know what line you're at, but the name of the class that you're executing is not one that's visible to the programmer. It's a compiler-generated class, so it will act similar to anonymous inner classes in that sense. But maybe if debuggers get smarter, they can do a better job of that. The debugger certainly will know what the enclosing class is. That's part of this structure of the name of the compiler-generated class. There's something in gray here I'm not going to tell you in detail, but anonymous inner classes restrict what you can do. You can't return from the enclosing method. You can't access non-final variables. And for some APIs, those restrictions are important. There's a way of expressing that you want those restrictions on certain APIs so that people don't do things that they ought not to do. Yes?
What's the type of a closure which passes an exception through to the caller, which you don't want to?
OK, so the question was, what's the type of a closure that throws an exception that you want propagated out to the caller? The question confuses the control invocation syntax with a closure. A closure is just a method. It either throws an exception or it doesn't. Okay? Every exception thrown by a closure that's actually thrown at runtime, the person who invoked that closure gets the exception, whether they like it or not. Now, you can write APIs that receive a closure that somehow take the closure and do something with it, or there's a way of expressing a compile time that they pass them on through for runtime type checking. But that's not part of this part of the proposal. That's part of something called exception transparency, which I'm not going to talk about in detail. But it is explained how you write such APIs and the specification, how you write APIs that are exception transparent.
So if you wanted to use this with existing APIs, you would not get exception transparency?
Right. If you want to use this with existing APIs, you would not get exception transparency. In particular, runnable, the run method does not throw any exceptions. So if you want to use, if you end up using an API that receives a runnable, and you try and pass it a closure that might throw a checked exception, you are going to get a compile time error. The compiler will say, I'm sorry, this closure throws an exception, and I'm trying to create a runnable, and it doesn't allow you to throw any exceptions. You're going to have to deal with that. Okay? So that's a little bit unfortunate, but in a sense, that those are restrictions on the existing APIs. My hope is that the function types, once they're added to the language, it will make it easier for people to write APIs that are exception transparent.
Does executing a return statement, is that specified as any kind of exception?
It's specified that if you execute a return statement and the method invocation that you're attempting to return from is not on the current call stack, that you'll get an unmatched non-local transfer exception. But it turns out there are even things you can do to hide those and shuttle them across threads to make them return from the right thing. I'll mention that again, I think. So with what I've told you so far, you could make a method, you could write a method called withLock that takes a lock and a closure. And the way you would write that method is you would write it that it receives a function type that takes a no arguments and returns a void as its other argument. And you would be able to use it this way, right? So you pass a lock and you pass a closure. And the way you write a closure is an open curly brace, no arguments here, the arrow, and then the statements. And here we're not providing, there's no results, so there's no final expression. Close curly to close the closure, close paren to close the withLock invocation, and semicolon to end the statement that's the invocation of withLock. And this is not bad, but it's certainly not as convenient as the built-in synchronized statement.
What is withLock a method on?
You can statically import it from wherever you want. And if you don't like the question is what is withLock a method on? I would expect it to be a static method somewhere that you would statically import. or import, or maybe you'd qualify it. Maybe you say locks.with lock. It's a matter of taste and style how you invoke it. So I'm assuming that you have static import Java util concurrent locks.with lock at the top of this program in order to be able to do something like this, and that we've added such a method somewhere. But this is not as convenient to use as the built-in synchronize statement. And the reason is, with most of the built-in statements, you sort of remind yourself by the indentation level how many closed curly braces you need to put. Well, that's not enough here. Not only do you need to remember the closed curly brace, but you also need to remember the closed paren, and you also need to remember the semicolon. And that might not seem like much of a burden, but it actually is, especially if your method is more than a couple of lines long. You really want the user to be able to not have to remember more than the closed curly brace. So this is a new invocation syntax, a method invocation syntax, that's proposed as part of the closures proposal. And it means exactly the same thing as the previous line. So the idea is, if you have a method invocation where after the closed paren, you see an open curly brace and a bunch of stuff in a closed paren, that is a statement form, and it means to package up that block as a closure and pass it as the last parameter to the method. Yeah?
So can you write something with more than one closure?
Can you write something with more than...
If statement.
The question is, can you write something with more than one closure, like an if statement, as conveniently as this? With the current specification, the answer is no, but you can still use the closure syntax with the curly braces and the arrows. The problem with doing something as nice as the sort of if and then is you can't tell whether the then is a new method invocation as a separate statement. The fact that it appears in the same line as the closed curly brace. You see, this closed curly brace at the end here ends the statement. We don't need to look any further to see what else is part of the statement. If we allowed another word here and then another block, you can't tell whether it's one statement or two statements. I wrote a recent blog post about how to deal with this kind of situation. I don't know whether it's very important to be able to have those kinds of statements, but if it does turn out to be important, I think that's probably something we could do. So far, those use cases seem to be more rare, but maybe that's because I'm only looking at very simple things. For the moment, we're only looking at the use case where there's a single block of code that you're trying to do under control. In a sense, there are things like loops and all of the sorts of things where you would use advice in aspect-oriented programming, those kinds of applications. And callbacks, for example, registering callbacks and forking off threads. Here is the formal syntax for one of these new kinds of statements. I call it a control invocation statement. And the idea is you have a primary, just like you have a primary in an ordinary method invocation, an open paren, and you're allowed to have a bunch of formal parameters here. And I'll show you what those are in a couple minutes. Then a colon, and the formal parameters in the colon are optional. So you can also do without those. And then you have an expression list, and then a closed paren, and then a statement, single statement. And what this is translated to, what this means, is exactly the same as if you had written same primary, the same expression list, and one final closure. The formal parameters to the closure are the formal parameters that appeared before the colon, if any. And the closure only has one statement inside of it, and that's the statement that was the final statement at the end here. Now, of course, a statement could start with a curly brace and have lots of stuff inside it and end with a curly brace. But you only get one statement there. Finally, close curly for the for the end of the closure, close paren for the end of the invocation, and a semicolon, because this is a statement form. It is not an expression form. Yes, question?
When you run this at runtime, are you creating an instance on this interface?
So the question is, when you run this at runtime, does this mean you get some instance of an interface? Every time you evaluate a closure expression, you get an instance of some interface, typically anonymous instance of some interface. And in general, every evaluation of a closure will result in a new instance of some interface. Now, sometimes they can be optimized away. The compiler can determine that it can use one for all of them, and it will only create one. But in general, you'll get a new instance every time you evaluate a closure expression. But you know what? On modern VMs, allocating a new object is just bumping a pointer. Memory allocation and garbage collection are very, very cheap, especially when the garbage is very transient. This is the sort of thing you have to write to use the locks that are part of the concurrency framework. Yeah, there's one more question.
With this syntax, anytime somebody forgets a semicolon, like if somebody forgot a semicolon on the second line here, it is trying to turn it into a closure invocation?
Well, in this example, if you forget a semicolon on the second line.
My locked up block line.
Pardon?
My locked up block.
No, well, yes, but it's unlikely that it will find a lock method on Java util concurrent lock that accepts a closure as a parameter, you see. So yeah, it's possible that the compiler, if you forget it, yes. So the question is, if you forget a semicolon, does that mean the compiler is going to try and do one of these invocation? And the answer is yes, but the chances are the compiler is not going to find anything to invoke. It would be very strange to have a method overloaded, one that takes a certain number of parameters, and another one that's exactly the same that takes a closure.
One that takes either no parameters or
right, or a closure, yeah.
Or an object.
Or an object, for example, yeah. That would, yeah. Generally speaking, overloading is a bad idea anyway. But it's unlikely that you would get something that would be meaningful. But yeah, in theory, you could. But on the other hand, if you forget an argument in an invocation, it's possible you'll invoke the wrong thing also. But yes, if you forget a semicolon somewhere, you can end up attempting to do an invocation like that. So that suggests that perhaps the compiler should be careful to point to the beginning of the statement when it gives you an error message that it couldn't find anything to invoke. The close paren perhaps would be a good place to point. So this is what you have to do today to use the lock from the concurrency framework. Right? First you lock the lock, then you have to use a try finally, then you put your business logic inside the try block, and inside the finally block you have your unlock. And this is what I did in the calendar server I mentioned recently. I turned some native locks into concurrency locks. Fortunately, I only had to do it in a few places because this turns, this adds quite a bit of boilerplate to your code to have this interspersed with your business logic. And as I said before, this is the sort of thing that would be a little bit better, where you use your with lock method and pass a closure as your last parameter. But even better yet would be to use the control invocation syntax. So this is what you get using the control invocation syntax: locks.withlock, pass the lock, and then as a final extra parameter, we pass the closure that actually does the work that we want to be controlled by the lock. So now, not only does it act like a built-in statement, but it looks like a built-in statement. But you know it's not a built-in statement because this is not a statement keyword, right? This is an ordinary identifier. And you can look it up in your IPI documentation. You can hover over it with your IDE to get the Java doc popped up. Just like any other method invocation, you have all of the resources for learning about it and understanding it that you have with ordinary methods. Here's another of the kind of things that will start to be possible when you have closures in the language. There's this thing called map in the functional programming community, and it means sort of the same thing that we mean when we say map reduce inside of Google. But unfortunately, Java already has this thing called map, which is a data structure. And it gets a little bit confusing, but ignoring that for the moment, wouldn't it be nice if we had the functional programming equivalent of map, right? It's something that takes a list, and it takes a function that goes a list of X, and it takes a function that translates from an x to a y, and simply does that translation on every element of the list and returns a new list, which is a list of y's. And naturally, you'd probably want that to be in collections, because that seems to be the place where we throw all of our static methods on collections. And you'd be able to use it this way, right? Collections.map, a list of some sort, and you simply write a closure as the other argument that does the translation that you want. This is the sort of thing that you might frequently see in functional programming style. And I think that with the addition of function types and closures to the language, this becomes easy enough to express that it's worth adding to the libraries in Java. So what about existing APIs? For example, there's this executor framework. This is Java util concurrent executor. It's an interface that takes a runnable, and depending on what implementation of that interface you use, it forks off another thread or pulls a thread out of a thread pool and causes the runnable to be done by that background thread for you. It's a very useful facility, but in order to use it right now, you have to write this anonymous inner class. You new runnable, public void run, do something, and you have to count your closed curly braces and your parentheses and your semicolons, which is a little bit of a pain, but IDEs help. I don't want to throw out those interfaces. I don't want to throw out the whole concurrency framework. It's a very useful framework. It should work naturally with closures. And because of the closure conversion, it does. You can write this way. You can write, if you have an executor EX, ex.execute, open paren, and then between the parens, you write a closure. Open curly, arrow, bunch of statements, close curly. In fact, you can even use the control invocation syntax here, if you want, to do it this way. Now, when the thing that you're doing is not being done immediately, I personally prefer not to use the syntax. I prefer the syntax with the arrow, because if you're just sort of skimming the code, it kind of looks like this is being done sort of here and now in the context of the program, and it isn't. This is something that's going to be done in another thread at some other time. But it is possible to use the syntax, and maybe it'll turn out that once people are aware of the syntax, it won't be unnatural to use this for things that are run in other threads. Yes.
If you had a return in there, and then your closure gets executed in another thread,
yes,
does the function return twice in two different threads?
So the question is, if you have a return inside the closure, does that mean your function can return twice? So this is, I think I heard this question recently in the guise of, does this mean we get continuations for free? Yes, and the answer is, if you execute a return statement for an invocation of a method that is not currently executing on the current call stack, you get an exception.
If the closure was called in a separate thread, and this went off and do something else, or it's still on the call stack?
No, it's not on this current thread's call stack. It's on another thread's call stack. Yeah, so the call, yeah. So the short answer is no. On the other hand, you can use closures to do some of those kinds of things, but not simply that way. So one of the things, one more example, adding a swing listener. This is the sort of thing you do today. Item listener is actually a base interface that's used throughout swings for things that you can you can listen to. And the way you add something is you call add item listener, and it takes a item listener, which is another interface that you have to implement, and the method inside it is called item state change, and it takes an item event because there are different kinds of events. And this is what you do when you want to add a listener in swing. Well, because of the closure conversion, if you want to do this with closures, this is what you would have to write. is.add item listener, and you simply pass it a closure, item event E, arrow, do something with E and IS. And in this case now, IS doesn't even have to be final, probably. Or maybe it does have to be final. It depends on whether or not you retrofit the interface to require the restriction. Yes, question?
Looks like we're trying to do the target for this conversion. We're going to convert to either an interface with one method or an abstract class with one abstract method?
So the question
is it a little more devious than that?
So the question is, it looks like when we're doing this conversion, we're either going to go to an interface with one method or an abstract class with one method. The answer is it only works for if you're converting to an interface with one abstract method. And the definition of abstract method is complicated because you can actually have the same method with the same signature coming from multiple places and different return types. But that's basically it. You cannot use this for classes that have a single abstract method. For technical reasons having to do with a part of the specification that I haven't told you anything about. So I'm not going to tell you why. Yes? I'm sorry, what?
Could you rewrite this using the control abstraction?
Could I rewrite this using the control abstraction? Well, that's a question that would make me smile. And the reason is, when you try and do that, you get this little colon before the close paren, because you have formal parameters, but you have no expressions. So you end up with smileys in your code if you do that sort of thing. But yeah, you can use the control invocation syntax for this sort of thing. But again, as I said, I don't prefer that. If you're writing a closure that's going to be executed at some other time in some other place, I think it's more natural to use the closure syntax rather than the inline the control invocation syntax like this. But you can do it, yeah. I promised to tell you something about some of the new APIs that I think deserve to be added to the JDK, but have sort of been waiting for a way to express them. A bunch of things in collections. I'll show you, remember the for each loop? Okay, well, we already have the for each loop as a statement, but there are things like the for each loop that I think are worth doing. I mentioned the concurrency with lock. I haven't mentioned closables, but there's something in C# called with, where it closes something for you automatically at the end of a block. And that's a very useful facility, and there's a lot of boilerplate in Java that you have to write because you don't have anything like that. And you could add a statement form to the language in Java, but if you have closures, you actually don't need to add a statement form to the language because you can do it with an API, and I'll show you how that would look. I did mention aggregate operations. I gave the specific example of map, but there are many more of those, and all sorts of things from the functional programming community that I think are worth adding. So as for the collections API, it's nice to be able to iterate over a collection, but there's this other basic interface in collection that right now there's no way of iterating over, and that is map. So if you want to iterate over a map today, you have to ask for the entries, and you write an iterator that maps over that iterates over map.entry of, well, in this case it would be key comma value. And then inside, you probably want to declare local variables with the right names, so you don't have to say entry.key and entry.value, which gives you no idea how it relates to your business logic. So the idea is, I think you should be able to write a loop that loops over the entries in a map. And here's what I think the programmer should be able to write. If you have a map from key to value of some kind, you should be able to write each entry, key k, so you get to name your variable in a way that makes sense in your application, value v, colon map, close paren, and then a block of code, or maybe you don't even need a block of code. If it's only one line, you don't need the curly braces. Personally, I like the curly braces, although maybe that's just because the style guideline here tells me that I should put the curly braces in. But here inside, you can operate with local variables k and v, no problem, and you can do anything that you would be able to do in an ordinary for each loop. You return from the enclosing method, you can break, you can continue. It's no big deal. What is a big deal is that you can write this as an API, that someone can just put this in the library. You don't need to get a JSR together and edit the Java language specification and figure out how the rules interact with all of the other rules in the language. You can just write a method that does this. And if a map, Java util map wasn't in the JDK, it would be completely hopeless to get this kind of language extension. But you don't need a language extension if you have closures. I already mentioned being able to lock using Java util concurrent locks. Briefly, this is a common problem. You open a stream and you want to do some stuff with a stream, and when you're done, you want to make sure it's closed. Whether an exception is thrown, no matter how you get out of the block, you want to make sure you close the stream. So here's what I think you ought to be able to write. With, and then you declare the type of your stream variable, a colon, and then here's the expression that opens the stream. And then you simply have a block of code. The with method is responsible for making sure that the stream is closed when you're done. And one of the neat things about the control invocation syntax, because it takes a statement, not a block statement, but a statement at the end, if you need to open 3 or 4 streams, you can just say with input stream s expression, and then before the open curly brace, with output stream, another expression that opens an output stream. And you can do those both on the same line so that you only need 1 pair of curly braces around the body. And that way, at the end of the block, both of your streams are closed in the reverse order in which they were opened. That's not something that you can do easily with a with statement in C#. Pardon? Yes, the with method would have a try finally block and invoke the close method on the stream after invoking the body of the closure. Yep. Yeah, it is odd. It is. He said it's odd that you have the open in one place, that is here in the expression, and the close in another place. That's true, but what you can think of is the purpose of the with statement. You're calling the with statement to do the close, right? So you could think of the with statement as, from the programmer's point of view, that is the close. So you actually have the close here. You're calling a utility method to do it for you, but you're doing the close here explicitly by calling with. So I mentioned map. Here's another related operation. This is reduce. And this is the reduce operation takes a list of something. In this case, we have an example where we take a list of integer and a binary operation on those, which is associative. And it sort of operates pairwise, summing up all of the results in the list, and finally gives you the one unique answer of doing that operation pairwise. And of course, you could write this as a loop. But one of the interesting things about having this operation is if this operation is much more expensive than simply adding 2 ints together, then you might want to do those operations instead of sort of chomping from the beginning one by one to the end of the list. You might want to do it pairwise concurrently. So maybe you would have a version of this reduce operation that takes the same arguments but also takes an executor from the Java util concurrent framework. It would take an executor that you can use to fork off threads in the background. And you could do this concurrently using a whole bunch of threads. But what you would have to change in the caller here is you just have to add 1 extra parameter that is pass the executor in as an argument. And it would automatically fork off the bunch of tasks, wait for them to finish, and then join them all at the end, and you're done.
If you did that, could you pass exceptions out?
Pardon?
If you did that, could you forward exceptions out?
So the question was, if you do that, could you forward exceptions? So yes, it would be possible to define the reduce operation in such a way that the closure that it receives is allowed to throw exceptions, and those exceptions are propagated to the caller. In fact, you could also make it so that return statements worked and returned from the caller if you wanted to make the reduce operation work that way. I'm not sure it makes sense to do it that way, but that would be when you're making the API reduce method, you would have to answer those questions of whether you want exceptions to be propagated out, whether you want return and break to work. And you would have to, in the implementation of that reduce operation that uses concurrency, that'd be a non-trivial amount of work to do to make sure that the exceptions get shuttled across and so on. But from the programmer's point of view, if that's the way you want it to work, it would be very convenient. Yeah. question.
Are these part of your suggestion for the standard, or are these just examples?
These examples are not yet in the draft specification. I think that figuring out what sorts of APIs to add is at least as large a task as doing the core language extensions, and I want to have a lot of help doing that. Doug Lee is working on the fork join concurrency framework, and that includes a lot of these like map and reduce operations. And I expect to lean on him a lot as far as the proposal for what those operations should look like. The stuff that makes it interoperate with the existing classes, you don't have to do anything. Not very much. There actually are a few things that are valuable to do that you can do without breaking backwards compatibility. But for the most part, I'm focusing on the language issues. And my hope is that someone will create a JSR for adding this to Java, and that JSR will be composed of an expert group, and those expert groups will contain people who are interested in various APIs within JDK, and they'll brainstorm about what all of these areas should be. But I'm sort of using these more as examples of where I think the JDK would be likely to go if closures were put on the table for JDK 7. So I did mention that Doug Lee is working on what he calls a fork join concurrency framework. It includes a lot of these primitives that you see from the functional programming community. I think there are probably others that are worth adding. There are a lot of things that people currently do with aspect-oriented programming that are possible to do not quite as conveniently, or maybe more conveniently depending on your point of view, with closures. For example, I showed you how to do timing operations, how to do locking operations. You do logging operations sort of before and after various operations. If you think of those as advice in the aspect-oriented programming community, closures provides another way of conveniently adding advice into the source code of your program. And there are some things like continuations, like bounded continuations, that are easier to do in a library without language changes, without VM changes, if you have closures in the language. My hope is that someone other than me will explore that in more detail, but I have some ideas along those lines. Again, as far as the APIs are concerned, I'm personally mainly interested in the language issues and getting a prototype out for people to try. But at the same time, I hope that the prototype will have a lot of these examples of what I think ought to be done to the JDK in the context of the prototype, for people to try out, see what they look like, and see what they feel like to use. Because just having a language extension with no sample code is very hard to judge, sort of what you have. Some references. There's a homepage for this. It's www.javac.info. It used to be my homepage for the Java compiler, but I've repurposed it to be the Java closures homepage. Currently, the only thing that's there is the current version of the specification, but I expect to have not only a history of all of the versions of the specifications, but the open issues list, and maybe even a discussion board for people to comment on it. Currently, most of the comments on this work appear on other people's blogs or comments on my blog, because I do tend to write about the motivation for the changes from one version of the spec to another. There's also my blog, gafter.blogspot.com. The other people that have been working on the specification with me, Peter Ahe, here's the URL for his blog, blogs.sun.com/Ahe. He's the lead of the Java compiler development at Sun Microsystems. He was one of the implementers of the wildcards part of the generic type system that was added in JDK 5. Gilad Bracha was also participated in the specification. He has wrote a couple of blog entries, although he's no longer with Sun Microsystems, so he's less interested in this stuff. He's working on Smalltalk lately. James Gosling worked with us on some version of the specification. I'm not sure exactly where James sits on this issue. He's written a few things that can be read either way. But some of the things like the control invocation syntax came out of ideas that he from our discussions with him. And finally, of course, this Wikipedia definition of closure, which, in my opinion, sort of supports our position on what closures are compared to the alternatives. But that's, Wikipedia sort of varies from day to day, and maybe part of the reason it supports my position is because I contributed to it. So, there any other questions? Wow. Okay. Yes.
So, with closures, you always get this question of how do closures interact with mutable, locally scoped variables?
Yes.
Suppose I have a loop in which I declare a mutable variable.
Yes.
And also inside the loop, I create a closure. So each time through a loop, I'll create a new closure. Do they all refer to the same variable or different ones?
So the question was, how do closures interact with mutable local variables? Do they all get the same version of the variable, or do they all get their own version of the variable? The answer is, if they're all, for example, if it's inside of a loop, and the variable is defined inside the loop, and the closure is defined inside the loop, you have a new logically, you have a new variable on each invocation of the loop, and therefore they are each referring to a distinct variable. On the other hand, if the variable is defined outside the loop, then logically you have a single instance of the variable that all of those closures are referring to. In other words, closures don't change the way variables come into and go out of existence. They just make some of the issues a little bit more obvious where the question doesn't make sense without closures. But essentially, if you think of executing a variable declaration, okay, if when you execute the variable declaration, the variable comes into existence. If the closures are referring to the same variable where the declaration was executed, right, the same execution of that declaration, then they're referring to the same variable. If the variable declaration was executed again in between those definitions, then they're referring to different variables. I hope that answered your question. I'm sorry.
In terms of implementation, you're just boxing the
So the question is?
Implementation, you're just boxing the lexicon, right?
So the question is, in the implementation, you're just boxing the lexical scope, right? Well, it's not quite that simple. And the reason it's not quite that simple is you take the example of a loop. Java does have loops, unlike something like Scheme that doesn't have loops. The variables that are declared inside the loop have a different lifetime than the variables declared outside the loop. So they cannot be boxed together. You have to box them separately. So you cannot create a single box for the entire lexical scope. Yeah, but you do end up boxing up the lexical scope, perhaps in multiple boxes.
So then you can also get into cases where if you have nested loops, you can get a scope break out of the inner loop after it has already been exited.
No, you can't. Yeah. So what happens if you're using closures and you have nested loops, and you're no longer in the inner loop, but you try and break out of the inner loop? And again, if you try and break out of a loop that's no longer executing in the current threads stack, then you get an exception, an unmatched non-local transfer. Okay. And it's an unchecked exception, so you have to deal with that. And it's a programming error. I don't know what else to tell you. But again, the sort of things, I don't expect that you're likely to see concurrent loops that don't provide explicit support. If you have a concurrent looping construct, then I would expect that breaking out of the loop would terminate all of the threads that are executing as part of that loop before it lets you out. If, on the other hand, what you're doing is you're forking off threads, then hopefully the API won't even let you return in the first place. And there is a way of defining in the API in such a way that you can't easily simply return. You can restrict it in the same way that it's restricted in anonymous inner classes. Okay. Yeah.
You showed a lot of examples on how to use, how to call a method that
Yes.
takes closure, but not on how to implement a method that takes closure.
Yes,
Can you type stuff in and show us?
Yeah, so the question is, how do I write a method that receives a closure? So let's see here. So first thing I need to do is well, I can't mirror onto that, but okay, so there's WordPad. There we go. Okay. All right. So how about with lock?
Sure, yeah, that sounds good.
Okay. Well, remember I mentioned there are a bunch of things called transparency. I'm going to start by ignoring transparency. Yeah, I'm going to ignore exception transparency. I'm just going to write a simple with lock that doesn't work with exceptions. So void with lock. It takes a lock, and it takes a say an ordinary block of code, block. We'll call it, oops, yeah, block. And inside we have lock.lock, try, block.invoke, finally lock.unlock, and done. Okay? So that's with lock. And I think it's straightforward, right? It's sort of obvious. Now, when you start saying, well, what if I want it to be known that the exceptions on the inside are propagated out, it gets a little bit more complicated. So let's suppose you want to do that. Okay, well, since you don't know what exception types are going to be thrown, we have to make a type parameter for that. And I'll use X for the exceptions. And now, so this block can throw X, and here, this can throw X, okay? Right, so we want to say whatever the block can throw is known to be thrown by this. Yes, thank you. Now,
The other one should be rows.
yes. This is WordPad. Yes, okay, so now this is still not quite right. And the reason it's not right is you have to have an exception.
Oh.
Okay? What if you don't throw anything, right? This isn't quite right. So now I'm going to need a little space to fix that. So there's a little change here. There. This is part of the specification. It's a new kind of type parameter. It can take 0, 1, 2, or 3, or any number of type parameter, of exception types, okay? And what this says is, however many exception types are thrown by that block, those same exceptions are thrown by with lock, okay? And this is how you get exception transparency, okay? Now, there are other types of transparency that this doesn't provide, okay? So I'll do one more, and it turns out it's the only one that you actually have to change the code to do. The other one is something called completion transparency. The idea is when you use synchronized, if you have a return statement inside the synchronized, then the compiler knows that synchronized block will never finish. It won't complain, oh, you forgot to put a return at the end of your method. It knows that you can't reach the end of the synchronized. Okay, but if you use with lock and you have a return on the inside, the compiler doesn't know for sure that you're going to execute that block and never come back. Okay? So if that's the case, you need to have some way of expressing that. And the way that works is, I'll make a return type for this method, and we'll return that type here. And instead of returning void, I'll return the type R here, and I'll return block.invoke. And you might wonder how that solves the problem. Well, it seems obvious this solves another problem, which is what if you want to avoid the expense of a return? Return actually is going to be implemented under the covers using exceptions. If it's frequently executed, the VM is actually going to inline it and optimize it into a jump. But if it isn't very frequently executed, you're going to pay a little bit of an expense for that. So this allows you to use a with lock as an expression and have the resulting value from the closure be passed out to the caller. And that's sometimes convenient. But what's more important is that the result type, if you use this in the normal way, where you don't return, you just have some statement, the compiler is going to decide that the result type R is not void. Void isn't an object type. It's java.lang.void. It's a new type that's being added. It's just a placeholder. Okay, it means no value, and the value is it's actually going to return at runtime is null. But if the block does not return normally, if you have a return statement, for example, as the body of the block, the compiler is going to infer that the type of the block is something called unreachable, java.lang unreachable. And unreachable is special to the compiler. The compiler knows that whenever you have a value of type unreachable in hand, you cannot get there. So because when you have this with lock with a return inside, the compiler knows that the closure returns the type unreachable, and therefore with lock is going to return type unreachable. And the compiler is going to say, oh, a statement, it's a method, it's a function, expression statement whose result type is unreachable. I know this cannot complete normally. And therefore the compiler will not force you to put statements after that with lock. So this provides you with completion transparency. And as I said, there are a couple of other types of transparency, but they don't require you to make changes to the source. Yes?
Taking another second closure, will X have the exception spec for both of the closures?
Okay, so the question was, if you take another closure, will X have the exception spec for the other one also? Well, you can do it any way you want. You can declare two throws type variables, one for each one, and you can say throws x comma y on the with lock. Okay, that would be one way of doing it. It depends on what you want to express in your API. But if you had two closures, each with an exception, and you know you're going to execute them both, and you want to say I can throw both of those, you would use two separate type parameters, throws x and throws y, and then you would say with lock throws x comma y. Yes?
You mentioned local variables are boxed. Does that mean I can access them after the method which evaluates the closure?
Yeah. The question was, I mentioned that local variables are boxed up. That is, they're packaged up into some object that exists at runtime. Does that mean that I can access them after the enclosing method has finished? And the answer is yes, absolutely, you can. Yes, yeah. Which means you might be sharing them among threads, and therefore you probably can mark them volatile, and you may have to synchronize around access to your local variables to make sure, because it's shared state. Didn't used to ever be shared state, but now, yes, local variables can be shared state. It's generally not a good idea to do heavily concurrent things using local variables simply because it's confusing. Yeah, it certainly is possible. Yes, you had a question.
So, for the not-so-bright programmer who comes across these calls to with lock,
yes, yes,
where they can't see directly, exactly what's happening in terms of pause and while and so forth. When they go and look up the definition of with lock, and it's got this R throws X, open curly, arrow.
Yes. What are they going to make? What are they going to make of this? Yes. So the question is, what about the dumb programmer, which, by the way, is always not the person who's asking this question, runs across a piece of code that uses with lock, and he says, oh, I better go and see what with lock does. And he comes over and he looks at this, and he says, oh my gosh, left arrow, comma, right arrow, R, throws X, close paren, open curly, what the heck is going on here? And if there's no documentation on this method, he's lost. Just like he's lost with any method whose invocation he wants to understand that has no documentation. Now, admittedly, there's some new syntax here that you're probably going to want to get used to so that you can understand code without having to read the documentation. But it is important if you're writing these control abstraction APIs that you expect to use frequently in your code, it's really important to make sure they're well documented. If you expect these methods are going to be used very, very heavily, it's even more important that they be documented. That's true of any method, though. If you have a method that you expect is going to be very frequently, have you ever looked at the signature of collections.sort?
Yeah.
Do you know what it looks like?
Well, I'm very unlikely to talk, but I've looked at similar things in C++.
So okay, so let me tell you what collections.sort looks like. Less than T extends comparable less than question super T greater than.
Yeah, yeah. I mean, one of the nice things about Java was it was a really simple language. All the complexities of C++ have been taken out.
So I don't think, as a practical matter, I don't think that anyone is going to have difficulty with lock, because hopefully it's obvious what it's supposed to do and it's obvious what it does. Yes.
The documentation brings up a point. Are there proposed changes to JavaDoc in order to document, for example, the parameter of the closure method that you would be taking here? Like, see what I mean?
So the question is, are there proposed changes to JavaDoc to support this? I expect JavaDoc will understand the syntax of types that's in the Java language at the time.
Right, but like, okay, so say you were going to document the parameters of this method, you would say @param lock,
yes.
and then describe the lock,
yes.
block,
yes.
and then describe the block, but then you've got the parameters of block, which in this case you don't have any, but maybe you, in another one you would have 2 ints. You need to say, what the heck are those 2 ints in your JavaDoc? You see what I mean?
Yes. So there are a couple of ways of dealing with that. And one of them is, you don't, I mean, if you need to document, if describing the function type is not enough, that is, if you can't simply say, a block that might throw an exception X, which is really what you want to say about this. You just say it's a block of code that can throw some exception X, because there isn't much to say about this block.
This one is not the example I'm talking about.
Yes.
I'm talking about what if, say it's not with block, say
yes.
it's like reduce.
Yes.
Yeah, where it's going to be taking
yes.
parameter, the block method itself,
right.
the invoke is going to have parameters.
Let me put it this way. You can, the documentation that you want to put on the parameter is very much like the documentation you want to put on the method that you would have had in an interface if this had been an interface.
Right, but for that, you
yes.
have its own documentation where
yes.
you do parameter.
Yes.
Parameter.
Yes. Yeah. Yeah. So you can still express these using using interfaces if you want, and you can document the interfaces that way. The problem is when you do that, then anyone who's interoperating with this API has to use that particular interface. And this is one of the reasons why function types are most useful. I would hope that there would be extensions to JavaDoc. I'm not doing them as part of the prototype. But I would hope that there would be extensions to JavaDoc to do that. On the other hand, I also would expect that it's very rare that you would have a function type that's very complicated.
Yeah.
For most of the time, you would just want to say block, can throw is a block that can throw an exception X. That is, you don't need to have extensive documentation about the individual arguments, because I don't think that it's likely that you're going to have many distinct arguments. Even in the case of reduce, where it takes 2 arguments, right, and returns something of the same type. Well, first, the 3 types are the same. So all you want to do is you want to say it's a binary operation that's associative, and associative and commutative. No, commutative, well, I don't remember. No, not commutative. No, but you want to say it's a binary operation that's associative. And I think that's all you need to say. You don't need to say, you know, the left argument this and the right argument that. If you really need to say much more, then you certainly would expect to have some extension to JavaDoc. And I don't have anything specific to propose. But I hope that if this becomes a JSR, that would be one of the subjects that the JSR would look very carefully at. How do you do that? Yeah. I think.
Just out of interest, what's the lifetime of objects that are in the same lexical scope as the closure but aren't referred to by the closure?
What's the lifetime of objects that are in the same scope of the closure but are not referred to by the closure? The short answer is you can't tell.
Well, I mean, there's no way. Like, if you have a very large memory usage, for example, that's up to the VM to.
Yeah. So, I mean, the point is you want to avoid preserving objects in memory that can never be referenced. Okay. And I agree with that. You should avoid preserving objects in memory that can't be referenced. And it's an implementation detail how you go about doing that. As a practical matter, I can tell you that the implementation is not going to box up. Local variables that are not accessed inside of closures are just going to remain local variables. I would have no reason to make them boxed up. But the longer answer is you don't know and you don't care, and it's none of your business. You know, yeah. Yeah.
So just a clarification. So the local variables are lexically scoped.
Yes, local variables are lexically scoped. Returns are lexically scoped. Breaks and continues are lexically scoped. Exception, exception machinery is lexically scoped. You know, the completion, the rules for what statements can complete normally, that's lexically scoped. All of the things in Java that are lexically scoped interact with closures properly. You know, in a language like Scheme, closures are really, really simple because there's only one thing that's lexically scoped, and that's variables. So that's why the definition for a closure says, variables are, the variables take their definition from the enclosing lexical scope. But Java has lots and lots and lots of lexical, it has the method namespace, it has the variable namespace, it has the meaning of this, it has the meaning of break and continue and return, it has the exception machinery, and then this, it goes on and on and on. There are all of these separate lexically scoped language mechanisms. And in order to have closures really useful, in order to be able to do things like control abstraction, you have to consider all of them. And you have to make sure they all interact what I call properly, quote unquote properly, in the way that non-MS classes, a couple of them sort of work properly sometimes. But for the most part, none of them really are fully work in the way that they need to. Did I forget the type namespace as well? And the label namespace, that's another one. There's a lot of them. So yeah, you have to look at all of them and make sure they all work properly. Yes?
Have you considered specifying a method name that this is a closure automatically? So if I say method object dot method, that this automatically becomes a closure. So I don't have to create a closure that just calls
yes. So the question is, have you considered some way where I can just say, variable.method name and have that method of that variable automatically can be converted into a closure or a function type that refers to the invocation of that method? The short answer is yes. The long answer is it doesn't actually buy you very much. So we haven't done anything to add it to the specification. But again, if that's really, that's something that a JSR could consider, and it would be, compared to the rest of the stuff that I have to implement, that would be very easy. But again, it's a sort of added mechanism that doesn't buy you very much. Normally object.identifier is referring to a variable in the variable namespace. You can tell one namespace the other by whether or not they're parens. So you have to do some really fun, you have to either add an ampersand operator so you can tell you're taking the address of a function or something like that, or some other syntax, maybe a pound sign, I don't know what you do, but it would have to be an additional syntax. And once you do that, why didn't you just put an open curly and an arrow before it, right? I mean, it's really not that hard to put an open curly arrow before it and then a closed curly after it, because it gives you exactly the same effect. And that's what the compiler has to do anyway, if we provided a shorthand syntax. Yeah, you have a different instance. You have to box up the instance with the method, and you have to know to invoke that method with that instance as the first argument.
Parameter names as well?
Pardon?
So you get the parameter names as well in the closure?
Parameter names?
Well, if the method has parameters.
Yeah, if the method has parameters, you have to receive those parameters and pass them on. And again, the compiler has to do that, but maybe you don't care what the compiler has to do, you just want it to work, right? But yeah, it's possible there are some circumstances in which case that would actually make things simpler. I don't think that there are many. I don't think it actually buys you very much compared to the complexity it would add to the language. But if it turns out to be important, then I don't feel that strongly about it.
So what we call a map on the collection and just want to call the same method on every object.
So yes, you're mapping over some collection. You want to call some method in the object. So why don't you put a open curly brace, say object.method, open paren, close paren, semicolon, and you're done. It's not. Yes, I know. I've seen the sort of abbreviations you can do in languages that allow you to sort of elide the parameter list that's implicit in the iteration. But you're not going to get that simply by this kind of syntax. That's not enough. You have to do a lot more. And doing something like that alone, where you turn a method into a function type or a closure, I don't think it gets you very far. So yes.
Have you tried doing multiple dispatch with this stuff to see if it looks any better than if you did it without it?
Have we tried to do multiple dispatch using this stuff? Personally, I like using visitors for my multiple dispatch.
That's two.
That's two. Yeah. So I'm not sure I understand how it would help you to have. I mean, you can build a table and you can sort of populate the table with a bunch of closures, and then you have some algorithm that looks up. No, but that's the sort of API that you might consider, right? You have a multi dispatch thing, and you have to fill in the table. But then you're doing all your checking your type checking at runtime, rather than at compile time, because you have to somehow keep track of what are the types of the arguments and what are your overload resolution rules, and what do you do when there's no best answer. And I don't know the answer to those questions. So the short answer is no. We haven't really thought about that. But that's hopefully there are lots of examples of APIs that people can start thinking about once you have closures that just weren't practical at all before, that people can try out these ideas and find out if they allow you to do something useful or not. Because I don't know. Maybe there is something that you can do that would be very handy.
So is there actually a JSR?
So the question is there actually a JSR on this?
Is somebody planning on actually opening one up?
Is someone planning on opening up a JSR on this? There's a long answer and, I'm afraid, a longer answer. I was planning on writing a JSR for this. Sun Microsystems actually asked me to submit a JSR proposal for this, but I can't do that because I am not Google's JCP representative.
You can't do it? Oh, I guess.
I cannot do it as an individual contributor to the Java community process, because as a Google employee, I cannot be an individual contributor to the Java community process. Google's JCP representative is Joshua Block, and he has other ideas about what should be done in the Java language in this space. And as far as I know, he is not currently planning on submitting a JSR on this. My hope is that creating a prototype, which, by the way, I'm doing on my own time, will be something that Sun can use as a justification for Sun creating a JSR to do this into the language. Because I think that's the only way that this is going to happen in Java at this point. Yeah. Any other questions? Thank you.